This show is supported by you. This is a cup o go for Friday, March 13, 2026. Keep up to date with the important happening in the Go community in about 20 minutes per week. I'm Itamar, and you're Shai.
And that's Shai, and I'm
Clearly,
Jonathan.
I'm pretty bad at this, and I can't hear you, Jonathan. But yeah,
Yeah, that worked great. We might include it in the bloopers. Mom, I'm on TV. All right.
So we're going to keep this. We will keep this in the show, by the way, because that's a perfect segue. My son was on the radio this week, and he was so excited.
Oh, wow. What did he do on the radio?
His preschool class took a field trip across the street to the local radio station, and they recorded a little, like the whole class sang. I don't even know what they said because I couldn't understand it, but the whole class recorded a little thing. My son was so excited. He was on the radio. He doesn't know what the radio is. Like, he was like, what's the radio, Papa? I'm going to a radio station.
That's so cool.
Yeah, it was a fun time.
Radio is fun technology. We should bring it back alongside blockbusters.
Maybe we can become radio DJs.
Oh, I could definitely. I listen to my favorite San Jose station. Shout out to 107.7 The Bone on the San Jose FM radio. You guys are awesome. I highly doubt that any of the 107.7 FM The Bone are listening. But if you are, baby, what's your name? Baby Zach or something like that? You guys are awesome.
Whoa. All right.
Yes. So first of all, this show is supported by you, and we'll get more into that in the ad break. Thanks a lot to all the new Patreons this week. We've gotten a big wave of support. We really appreciate it. But let's start talking about news. Usually we cover proposals, but I noticed they're lacking from our cards today. What's going on?
There is a huge backlog of proposals that are almost accept. So I think next week we'll have a lot to report on.
Yeah, but we want to wait until they cement, so we don't cover them 90%, and then next week we have to do errata fixes.
Yeah, we hate fixing our things.
We hate going to fix our things.
All right, what's up first?
Damn. Foreshadowing. So first of all, I wanted to follow up. We had an episode on Go vulnerability research. That was May 3rd, 2024. And yesterday, someone pointed out that, at the time of the interview, our interviewee, Bartek and Yannick that made it happen, they talked about Go vulnerability research and how much is it worth. And specifically how little the economy pays for a bug.
Oh, yeah.
And Yannick pointed out that governments buy 0 days. And at the time of the interview, he thought they were buying them to fix them. But since then, he has been made aware that the 0 days are also on the market for exploitation, which I thought, I don't know, to me it was obvious, but I don't know, maybe to you it was surprising?
I never thought about it to be surprised one way or the other, I guess. But
yeah, so if there's a market for 0 days and governments are buying them, to me it makes sense that they might buy them for exploitation and not only for fixing, just because they have the same incentive as anybody else who's buying them. Either they want to protect themselves or they want to gain an advantage. So there are 2 articles here about it. It's not related to Go specifically, so we're not going to talk about it too much. But if that episode interested you and that interview interested you, you can talk to Yannick about it here on the Slack thread. And it's a good opportunity to bring out an old episode. We usually don't do that, but episode number 61, that was a long time ago. But yeah,
back when I was still young and chipper.
Yeah. It was 2024. So episode number 61, we talked with Bartek Nowotarski, I hope I'm saying that correctly again, about Go vulnerability research. And now there are more thoughts about it. So interesting.
Cool.
But under that, we have a few new blog posts on the Go blog, which is always a nice resource.
What's the first one on the stack?
Nice. You know what? I'll put aside some space for that one. Oh, but do you have another one?
I do have another one. Yeah.
Oh, now I need to drop that list and create a new one because I only had room for one, but I need room for two. Anyway, so the first blog post is about optimizing allocations. Generally, one of the benefits of Go is that it's fast, right? Like when people think about programming languages, they're like, oh, Python slow, Go fast. But that doesn't just happen, because of the intrinsic qualities of the language. It's like not all compiled languages are fast. You know what I mean? Mm-hmm. One of the things that I've seen the Go team do again and again is make very pragmatic decisions to make the language faster for the general case, right? Just for general audiences. For example, we covered a lot green tea, right? The new garbage collector. But green tea works on stuff that's on the heap. And sometimes it's faster to do stuff on the stack. I'm not going to explain what stack versus a heap is. I hope the listeners know. If you don't, maybe pause the episode and go learn about it if you're like just a student or whatever. But I assume our listeners know what stack and heap are.
I think just a student, like that's some sort of lower class thing. Like I consider myself a student all the time.
Yes. I mean, a student is in first year of a university or whatever.
Beginner,
or maybe
yeah,
high schoolers. I don't know. Maybe we have non-adult listeners as well. Eat your homework. Do your vegetables. Anyway, the Go team has been working on ways to do more allocations on the stack. And actually, their example in the blog post is really, really good. So let's assume we need to allocate a slice of tasks, right? And I want to process them. So I'm getting a channel of tasks. I don't know ahead of time what's the size, right? So it's kind of hard to optimize. And then I'm starting to range over the channel and collecting tasks from the channel until I'm done. And then I have a slice of tasks. Is the workflow clear? I define var tasks and then I range over the channel and I just append whatever I'm getting from the channel into that list, into that slice, I mean. How big should I make the store for tasks, in your opinion?
It would depend on how much knowledge I have about tasks beforehand. And I would
try. So you have none. You just know that there's a channel.
If I have literally none, and I mean like about the domain knowledge, not about the specific like runtime knowledge, like domain knowledge. Like if I know that tasks generally is between 0 and 3 things, then I probably set a cap of like or a length of 3. If I know that it's likely thousands, then I'm going to do more.
Yeah, that's the first thing the blog post says. Like, if you don't define anything, it starts with 1 and then jumps to 2 and the old 1 is garbage. And then from 2, it jumps to 4 and then the 2 is garbage, etc. And then it jumps to 8. And again, now there's a lot of, it doubles the size of the allocation each time it fills up. And generally, it causes a lot of overhead in the startup of this task. If this is a really hot part of the program, you might just decide to switch out and just start with a bigger slice. So instead of just making a empty slice and then it starts with 1, you call make and you're like, oh, it's probably like 10 items or whatever. This is a pretty reasonable optimization. The surprising thing about that optimization, we're like, okay, I'll define, I don't know, a size of 10 to get rid of that like startup cost, especially if this is something, again, that happens a lot. So when I change it to make, how many allocations do you think I'll have? Assuming like usually there are at most like, I don't know, 8 tasks or whatever. Before we had the first allocation, right?
Yeah.
When we just allotted the stack. And then when it jumped to 2, there was the second allocation. Then when it jumped to 4, we had the third allocation. And when it jumped to 8, we had the fourth allocation.
Right. When
I call make and say, oh, it's probably 10. And it is really like probably 10. How many allocations do you think I'll get?
I guess I would expect 1, but since you're asking me the question, that must be the wrong answer.
That is. The surprising thing is that if you benchmark this code, you didn't reduce the number of allocations to 1. You reduced this to 0. Because it knows what size it's going to be, the compiler can put it on the stack instead of the heap. And what they're doing in this blog post is going through how Go 125 basically can optimize and know when to do stack allocation, even if you don't give it any information ahead of time. So even if you don't let it know, how much you're going to need, it figures out a way to do it automatically using a thing called move to heap. So it starts on the stack and then moves it to the heap before it returns it from the function. That's a Go 126 thing.
Where's the limit? Like what size would it automatically go to the heap? Like would you make with the size of 100 or 50 or 1,000 or something? Is it going to the heap directly?
So you don't need to, add this like length guess. It does a speculative backing store on the stack until 4. And then on the 4th iteration, the stack backing is full and now it's moved to the heap.
Got it.
So you don't do heap allocation for size 1, 2, and 4. And then that also means you don't create any of that garbage. So the garbage collector eventually will do a lot of work.
So it's essentially...
And if most of your slices are small, maybe you'll never have a heap allocation.
Yeah, so it's essentially free to do like make of size up to 4. But it's kind of also automatic now anyway.
Yes, because what it does, it creates... The problem is, let's say you create this, you consume all the tasks from the channel, right? And again, task is just an example. It can be anything. But you put it on that slice of tasks, but that slice of tasks is on the heap. And you're in a function, and then you want to return that slice of tasks, right? It's a super common operation. Take a channel, consume everything from the channel until you're done, and then return it on a slice because I want to do something with it. What's the problem now that it's happening on the stack?
It's only accessible within that local scope, right?
Yeah, it can't be returned because it's on the stack. And then when I pop out of that function, it's a little bit low level, but you pop out of the function, you lose the stack. That's how functions work. What they're saying is they, in 126, the compiler adds a runtime.move to heap function right before you return. So you can return stuff that's on the heap, that's on the stack, and it'll happen automatically as well. So even if you return it from outside the function, it's not going to start with the old method of doing it on the heap and creating all that garbage. It's going to do it all on the stack speculatively. And if successfully you avoided all of it, you just move it to the heap once. Which is, again, it's actually better than hand optimized code because it doesn't need the extra allocation and copy, only if you've done a stack backed slice and you return it, which is really cool. These are compiler optimizations, so ideally you won't notice them at all, but we'll just get a blog post from the Go team like saying, oh, we saw this improves that code base and this code base by X and Y%. I think for the normal use case of Go, normal, I mean like the common of network services, web services that deal with like network requests in a highly concurrent way. This can actually be super big. And I wonder if this is going to change the way I design Go programs to maybe deal with smaller things almost by definition. Like try to not handle more than 8 things at a time just to make everything go faster and never use the heap. I don't know if it's actually a smart optimization or should I just program normally and assume it's going to be okay?
I think generally you should just program normally and only optimize when you see a problem.
Yeah, that's for sure anyway. So a super cool blog post. I recommend you read it. It's very, very cool. If this one is causing negative performance issues for you, you can turn it off. There's a flag you can add to the compiler, but they do say if turning off this optimization, if you turn it off and it helps your performance, they ask you to file an issue so they can figure out why, because this is supposed to be strictly better. Yeah, very cool blog post. What else is on the docket from the Go Dev blog?
Let's move on to Microsoft's blog post. Oh, actually, no. Before we do that, I want to talk about something else. Let me inline this other topic first.
Nice.
All right. So this was just published a couple days ago on the 10th from Alan Donovan. It's about Go Fix, which we've talked about briefly on the show before. And I think you brought up a concern about Go Fix inline, the idea that you could, you have a function you've defined in your library and it's now obsolete and you want to replace it with something else. You can put a Go Fix inline directive, that's a specially formatted comment on that function. And if the person runs Go Fix, it will replace that function in their code with whatever's in your function. So it inlines that function into their code. And I think you brought up a concern about possible attack vectors here. Am I remembering correctly?
I was concerned, yes. But I
wonder if you could reiterate that concern, because I'm wondering if maybe this blog post addresses it.
My concern was, you add a Go Fix inline and you can introduce supply chain problems through it, right? Because I could say inline a thing to my function, and my function is like malicious or something like that.
Right.
That was my concern.
Those are concerns.
But I guess it's not a real concern, because if the library is malicious, you can add it anyway. You don't need a go fix trick to do it.
And
so I guess it's not valid.
Yeah, and since this is strictly inlining, it's already code you are already executing anyway. It's just being inlined, right? So it does a lift and shift. Like it takes the thing that you're already calling and executes it directly rather than calling it from a separate function. So I don't think that's a particularly valid concern, but
it's not.
This blog post really, I kind of knew this existed, and I've used it before through Go Please without realizing it was all the same mechanism. But what this blog post does is it talks about how source level inlining works with Go Please and Go Fix, and it's kind of cool. I mean, it's actually, there's nothing earth shattering in here. It's just kind of nice to see it laid out in a way that makes sense. And I did learn something from this. You can do Go Fix inline on non-functions as well. You can do it on constants, type aliases, and so on.
Why would I want to do it on a constant? Like if I rename the constant?
If you rename it or you move it to a new package, for example.
Oh, yeah, that makes sense.
Then you don't have to go through mechanically and change every caller. You just put Go :fix inline right above your constant definition, where it says Go const x equals other package.y or whatever, and then run Go Fix, and boom, your whole code base is fixed for you. The other really cool thing about this blog post, and maybe I've just been sleeping, but this is the first one I've seen with color in it. So there's some colored screenshots, and there's colored texts where it shows old and new, and with green and red diff syntax. So it's kind of cool in that regard. So just go look at it. Even if you don't read it, just go look at the pretty colors.
I like it. I think it's I'm glad that the backend team at Go finally discovered CSS.
Way to go, guys.
So should I worry about this if I'm a library developer? Should I worry about this if I'm just a normal developer? Will this just work out of the box for me? How does that impact my day-to-day?
Yeah, so I think there's two ways that you can look at this. The first is as a consumer. You can just maybe become accustomed to running Go Fix occasionally. Maybe every time you upgrade to a new version of Go or a new major version of a library, run Go Fix and it'll modernize your code.
Would you add it as a pre-commit, or is that unnecessary in your opinion?
I probably wouldn't, but maybe what I would probably do for my taste is maybe add it. You remember last week we talked about running your Go security updates every night, or upgrading all your dependencies, running it. I might do something like that, maybe once a month or once a week. Have a CI job that just runs and does a Go Fix and reports if anything's changed. Maybe I would do something like that.
That's interesting. Just keep it on the tip, and whenever you do a release, bring in all these changes. Ideally, all these changes are 100% harmless, right? Introducing running Go Fix shouldn't. It's like Go format. It shouldn't really matter.
Yeah, so they're virtually, it's even safer than Go format in a sense, because it's working at the AST level. I guess Go format does too, but Go format can mess up comments and stuff. But if you ever in your IDE VS Code or whatever, if you right click and do inline function, you're doing the exact same thing. You're exercising the exact same code path, which is one thing I didn't realize before reading this post.
Oh,
so that capability is built into Go Please, and it's exposed both through VS Code and through now Go Fix. The other answer to your question, if you're a library maintainer, should you worry? I wouldn't call it worrying, but this is a new tool at your disposal for deprecation of old things. So if you have you've rewritten the function signature or something like that, this is one way you could encourage the users of your library to update to newer syntax.
Cool. Well, generally, the more automated fixes we can do, the better, in my opinion. So
agreed. Anything
that can make that easier is nice. Now, after you're inline, going back to the Microsoft thing, now that we're out of the inline, although it's not really inlining like compiler inlining. So I take offense with your joke. A small non-Go related release in a different language. But wait, bear with me. I promise it connects to Go at the end.
I'm about to take offense at your other language. Go ahead.
Don't worry, it's not Python, it's TypeScript.
Oh, okay.
It's not Python. The learning language was invented just to learn programming. It's TypeScript. The lipstick they put on a pig that is called JavaScript, which is a browser engine, which for some reason is the number one backend engine here in the Bay Area. Anyway, TypeScript 6 was released. TypeScript 6 is the newest version of TypeScript.
RC, TypeScript 6 RC is released, right?
Yeah.
So it's not officially done yet, but the first RC is.
It is the last TypeScript compiler that is based on JavaScript. The TypeScript 7, which is already, I've tried to play it around with, it's not working that well, but for my project, which is a relatively complex, like real, multi-library, dependency heavy, a lot of typing, a lot of interfaces, a lot of edge cases sort of code base. But TypeScript 7 is very interesting because TypeScript 7 is 100% Go. We talked about this on the show when they started working on it, like almost a year ago, I think. But yeah, they're implementing the TypeScript compiler in Go. So why am I updating on TypeScript 6 if TypeScript 7 is the Go release? Is because the whole reason they're releasing TypeScript 6 is just to make sure that it's compatible to 7. They want to make their migration easy.
So this is the Go compatibility shim.
Honestly, it is a Go compatibility shim release. Very, very cool. Actually, I mean, technically, working on this stuff, I think is very cool. Just writing all these compilers, transpilers, and whatever.
Does that mean that TypeScript 7 will not have new features? It'll be feature compatible exactly with 6, but just written in Go? Or okay.
That's the idea they're pushing for. The feature will be that it'll be so fast that the workflow of, that I'm working with right now, which is like write some code, then run TSC, wait for a few seconds and see if you did something wrong, will completely change because you could compile the entire code base, on every character type because it's just so fast.
Right.
I think at least for my workflow where, I'm sometimes still typing by hand, but a lot of the things I do are agent based. Like I hope I would be able to connect the TypeScript 7 LSP directly to my like Claude or whatever. And they, instead of generating a lot of plausible looking code and then seeing all the errors and then adding on top of it as unknown as to silence these errors and hoping I don't notice, they would be able to get that feedback immediately. But it's just a way faster. I think it's like 100 times faster compiler. So it's a different, again, not TypeScript 6. TypeScript is still JavaScript, still super slow. But, this is basically a foundation for TypeScript 7. With TypeScript 6 being a precursor to it. I am planning, not right now, but when TypeScript 6 becomes a little more stable, like not the RC, I'm planning to move to it at work, 100%. I tried to move directly to TypeScript 7 and being an early adopter, but it just sort of didn't work. It was still too early. Like I actually did it the week we reported on it. So I think it was like 6 months ago or whatever. It wasn't ready yet. Hopefully it'll be ready soon. But I think it's cool.
Very cool.
That's all the news items we have for this week. We have a lot more in the backlog, but you know how it is. We just don't have enough time. Maybe we can inline some of them next time. But
we need to allocate our backlog better.
Yeah, for sure. I don't think that would make for a good listening experience. I think people actually like hearing us talk about whatever. Let's move to a quick ad break.
This week, we have a big shout out to 3 new Patreons. We'll get to that in just a second. First off, if you're not a Patreon yet, we'd love to have you. You can support the show financially to help pay for editing and hosting fees. You can also support the show less financially by just sharing the show with friends and colleagues and neighbors and anybody else. And maybe buying some swag. We have a swag shop. Head over to cuptogo.dev. There's a link there. You can buy mugs. You can buy T-shirts. You can buy stickers. Other fun things like that. Leave a rating and review for the show. Thanks for listening. Join us on Slack. We're on the Go for Slack in the Cup to Go channel. Did I get through it fast enough?
I think so.
All right. Tell us about the new Patreons.
I'm sure Josh Bleeker-Snyder appreciates us going through the ad very quickly because I know he hates this part. But Josh, listen. Philip Reinke, Alessandro Arzili, and Eric Tang. Man, folks, thanks a lot for joining our Patreon.
Thank
3
you
Patreons in 1 week. I don't know. For me, it's very exciting.
That might be a record.
I think probably the week we released the Patreon, we had a big influx of people joining, but it might be a record other than the initial week. And we really appreciate all 3 of you for jumping on the show. If there's anything, you'd like to let us know when you join on Patreon, you actually have a little survey thing that you can tell us what you want, but you can also just tell us on the Slack channel. We really, really appreciate it.
One last thing before we close out the episode, reminder, Trade's going to be out of town for a while. I'm still looking for co-hosts.
I really freaking hope so, because right now flights are not looking pretty.
Fair. I have enough volunteers, but some of them are repeat volunteers. So this isn't a guilt trip. We'll still have a show if you don't sign up. But if you would like to be a co-host for the first time, reach out to me. I still have 2 slots to fill in April. So if that sounds interesting to you, don't hesitate. Send me a message.
Cool.
I think that's it.
All right. Program exited, y'all.
Program exited. Goodbye.